All right. Hello, guys. Today, I want to talk about a very weird question I once got on an entrance exam. So, the question is over here, and it's basically saying that if f of x equals sine x, then prove that the first derivative of sine x is cosine x. And that really made me think about this question a lot. So I'll really quickly tell you what I did and what was my thought process. But before that, I just want to quickly familiarize some of you with a few trigonometric properties. So the first trigonometric property is actually saying that, so if we have sine a plus b, then that can actually be written as sine a times cosine b plus sine b times cosine a. And that's the first trigonometric property. And I will quickly prove this of like what it really means. So this is basically saying that if we have something as sine, let's say 10 plus another number, let's say 20. So if you go ahead and put this in your calculator, sine 30, you should get a negative number, negative 0.988 and some other decimals. Okay, now let's see if this actually holds true with our long equation. So if we go ahead and try and apply it, so if we have a sine 10 times cosine of 20 plus the sine of 20 times the cosine of 10, please go ahead and enter this into your calculator and see what you get. I'm going to do the same. So I got negative 0.988 recursive, so the exact same value. So this in a way is QED. That's a neat way of saying proved in mathematics. And then I want to show you a very similar rule, and I don't think I need to prove this one, but if you're very interested to prove it to yourself, we can apply it in a similar manner. So that was the sine rule, or rather the sine versions, but if we also have a cosine version, and it's a little bit different. So if we have a cosine a plus b, then instead of switching, we would say cosine a times cosine b plus sine a times sine b. So similar manner can be applied. All right, so this was the first rule I wanted to talk about. Another one is that if you want to take a derivative of anything, this rule always works. So it's very long, it's sometimes inefficient, but the beauty of it is that it always works. If you take a limit of h as it approaches to 0 of any equation, and you apply it within this formula, f of x plus h minus f of x divided by h, if you plug in the equation into this formula, you're guaranteed to get the derivative of it. Now, it will be very hard and disastrous, like if you want to apply, say, 2x, the derivative, you could just say it's 2, you can just use the power rule for it. But if you want to apply it to that, you'll get a long equation, but it will be sure to give you a result, as if you have a very much harder equation, say a logarithm or anything more difficult that perhaps rules are a little bit harder to apply for, it will work. So this is bulletproof, this equation. So this is how you get limits. This is how you get derivatives of anything. The last thing I want to introduce to you is that if we take a limit as h approaches 0 of sine h divided by h, or rather h divided by h. Now, this is not saying that h is necessarily 0. What it's saying is that h is infinitely close to 0. So it could be 0.11111 or something like that. And if you grab your calculator and put 0.00, let's say 1, divided by 0.001, so the same value, you will get a 1. So h divided by h would equal 1. So you need to realize that. So you can't just plug in a 0 over here and 0, because that's just undefined, 0 divided by 0. So what the limit is saying is that as it gets infinitely close to 0, then the result is infinitely close to 1. So that you need to understand. That's a little bit difficult concept. So now that we know this, we can actually go back to our problem. All right, so back to the problem. So let's see. So my first thought process was that, okay, so this is the derivative. So I'm going to use the never fail formula. So I'm going to say as limit of h approaches 0. Let's first write the formula, what it is, x plus h minus f of x divided by h. So I'm going to plug in sine into this. So that would be sine x plus h minus f of x. So f of x is sine x. So minus sine x and divided by h. So notice what we have over here, x plus h. So we can actually apply the rule that we just learned. So let's write it again. Limit of h as it approaches to 0 of sine x times cosine h. I should probably put this in parentheses, but yeah, plus cosine x times sine h and minus sine x. Perfect. Yes, it's very long, but the reason why I have to do this is because this, in this form over here, I can't do anything with it algebraically. So I gotta manipulate it to an extent so that I can work with it a bit. So what I can do over here, actually, what I notice is that I can factor out sine. So how would I factor out sine? So let's just write the limit as h approaches to 0. So if you factor out sine from here, it would get, let me actually come down here and write it. It would get sine x times, let's put a parenthesis over here, times cosine h. And the sine, another sine x actually comes from here. So -1, let's just write that over here because that can be one expression, plus cosine x times a sine h, and the whole expression divided by h. Okay, now if we were to plug in 0, so let's remember that this is limit as h approaches to 0, but if we were to plug in 0 for h over here, so we would have cosine 0 minus 1. And if you plug in cosine 0 into your calculator, you would get 1. So cosine 0 would equal 1, and 1 minus 1 equals 0. And anything multiplied by 0 will give you a 0. So let me grab another color. So this expression, sine x times cosine h minus 1, just equals 0. So we can just maybe perhaps ignore it now because it equals 0. So over here on the second part, we can see that there is a cosine x and sine h. So since we are taking the limit of h, we can take the cosine x expression out and take the limit of h as it approaches 0 of the expressions with h. So cosine x does not have h in it. It's not an expression of h, so we can just leave it out. We can't touch it, but we can touch this. So as sine h approaches h, and we just talked about this rule over here, so that would be a 1. All right, fine. So what do we have? It looks like a little bit of a Frankenstein's results. It's everywhere. Okay, so if I just rewrite it quickly, we would have a limit of h as it approaches 0 of sine x times cosine h minus 1 times sine h times cosine x divided by h. Okay, so we have a 0 plus sine h over h was just a 1 times cosine x. And that will just leaves us with cosine x. And here, if I may, I can write QED. So we just proved that sine x's first derivative is cosine x. All right, thank you guys for listening, and hope this helped.